Um, when I saw this structure, I was particularly intrigued by it because I've actually done some work with the precursor, that is the chemical compound from which it's formed. So I'm call your attention to the sterol on the right, which is actually derived biochemically from the sterol on the left. And the one on the left is something that's called fucosteral. And it's very, very closely related to cholesterol. So cholesterol, which you only find in animals, has a side chain where my thumb is. That carbon just has two hydrogens attached to it. So it doesn't have this other business here, this double bond with a carbon and a methyl group. Where you see carbon atoms attached at this position, this is called the 24 position. Where you see carbon atoms attached, you only see that in plants. So this being a plant, you would not expect to see cholesterol, but you have what is called 24-ethylidene cholesterol, and it has the trivial name fucosterol. And the richest source for this is a brown algae called Fucus fasciculosus. Now, my experience with Fucus fasciculosus goes back well over 50 years, because when I was a child, maybe even 55 years or more than that, 55, 56, 57 years ago, and my family used to take me down to Atlantic City during the summer, and I used to go into the ocean as a young child. There was a seaweed that you'd find, and you pretty much see this pretty nearly all over the eastern seaboard, at least the northeastern seaboard. I don't know if the southern states get it, but I've certainly seen this particular algae from probably Maryland up to Maine, and you can pull this out of the water during the summer, and it's got these vesicles, which are air-filled pockets on the thallus of the algae. And you can actually take these things. What we used to do when we were kids is we would take these things out of the water, and this was before the invention of bubble wrap. What kids do now is they use bubble wrap to get the same effect. And they pop the bubbles in the bubble wrap, and it makes that popping sound. And we used to do the same thing with the vesicles of the fucus when we pulled it out of the water. Now, little did I know when I was a child of 6 or 7 or 8 that 15 years later, I'd actually be working with this same algae and trying to extract this compound, fucosterol, from it. So in the early 1970s, I went down to Atlantic City again, put a bathing suit on, and with a professor friend of mine, we went into the Atlantic Ocean, and we actually harvested probably 100 kilograms, a couple hundred pounds wet weight of this particular algae, and we put it into these enormous 50-gallon trash bags and hold it back in a large van. We hold these bags back from the Jersey Shore to the university that I was attending at the time, Drexel University in Philadelphia, Pennsylvania. And I laid this out on lab benches and dried it, and then after it was dried, which took several weeks, it was ground to a powder, and we took the powder and treated the powder with an alcoholic solution of potassium hydroxide, and this causes what's known as saponification. So any fatty acids materials or materials containing hydroxy groups that could be converted into water-soluble products are converted, or thus converted, and these materials actually can be extracted into a water layer. And what is called the non-saponifiable fraction, which is the organic fraction that is not hydrophilic but lipophilic, is actually extracted into ether, and in that ether extract, through a series of purification steps that involved chromatography on silica gel columns, I was actually able to isolate from all of that material 5 grams of a highly crystalline and pure fucosterol. So this particular material was then used to do some radio tracer studies, What we needed ultimately was to have an oxygen here instead of this methyl group. So I used ozone, treated this material with ozone to put an oxygen in, on this position. And then we used a kind of chemistry that's called Wittig chemistry to reinsert radiocarbon at this position, so we could label this with a variety of radioactive labeled carbon atoms, and make another chain up here that would actually have these radiocarbon atoms. And then these materials were fed in small doses to rats, and we saw how they were metabolized in the rats by tracing where the carbon actually wound up, where the radio label wound up after the animal had metabolized this. Well, one of the natural metabolites of this, which actually is produced from molecular oxygen, but it's usually some kind of a excited form of oxygen. So it could be possibly from hydrogen peroxide, or more than likely it could actually be an excited triplet form of oxygen that's produced during the photosynthetic process. And the oxygen actually winds up adding to this carbon right here, and you get what's called a hydroperoxide, and that's the structure that you have right here. So when I saw this molecule, I immediately recognized that it was derived from Fucosteral, the material that I had spent a lot of time working up probably about 35 years ago. And isolating this compound, people have now isolated this compound and found that, again, it has some interesting anti-cancer activity.